Hi everybody. We've been working on a little bit of right triangles so far. You've done some measuring of some papers that have all of a similar angle type, 30 degrees, 50 degrees. And today we're going to eventually find the height of a crane in a situation. And we're going to do some math on that to figure it out. However, we need a little bit of review first. And we're going to review a couple things. Two are vocabulary words we should get through pretty quickly. One is the idea of a ratio, which is, it's a comparison of one side to another. That's how we're going to do it. If you need to pause the video quick to write that down, you can. It compares one side to another. So it could be length to width. Length to width if we were using a rectangle. And that's the ratio there. And the next vocabulary word is similar. And if figures are similar, the ratios of corresponding sides, are equal. And so what that means is, if that's a rectangle and that's x to y, and this is a similar figure, remember that from geometry, a similar figure, and this is a to b, then x over y is equal to a over b. Okay? And you learn that in geometry, that the ratio, if you do this divided by this, it's going to give you a number. And it's going to be the same as this divided by this. That's what we learn about with similarity. Okay, our next part of review that we want to talk about is review problem 1. The ski club is a ratio of 3 girls for every 2 boys. How many boys are there if there are 18 girls in the club? So the ratio is for girls 3, boys 2. And so it says if there are 18 girls in the club, so 18 girls, how many boys? A lot of ways you could do this. This times this divided by this. How did we get from here to here? Well, let's do the same from here to here. You will end up getting an answer of 12. So that's kind of using a proportion and just kind of understanding a ratio. So show the work for number 1. That one's pretty easy. We'll spend a little bit more time on number 2. Number 2 says, a rectangle's ratio of length to width is 0.44. So here's our rectangle. And here is our length. Here is our width. We don't know what they are. But if you do length to width, if you do length over width, and do that division, it will give you 0.44. That's what we're giving you. We know that. This is, again, something you did in geometry, I think, last year. Okay, so what's the next part of the problem? A similar rectangle has a width of 28.5. So if the width is 28.5, length to width, and there's our width, the ratio is 0.44. So how do we find the length? Well, solve the equation. Divide by 28.3, so by 28.5. So multiply both sides by 28.5. Length will equal 0.44 times 28.5, and you will get 12.54. Okay, so that's the length. So the length will be 12.54. The width we gave you was 28.5. Now, my apologies, visually, this doesn't quite match up. Okay, so it's not drawn to scale, but the figures just kind of show that's what it would be. Let's go back just to make sure it's okay. The ratio of length to width is 0.44. So if you do this divided by this, you will get 0.44. Okay? And this is similar to what you did with your triangles, right? What we did the other day was we did opposite over hypotenuse. We got a length, we divided it by another length, and we got a decimal when we did that. Okay? So that's going to connect with what we do. You need to be able to have that skill. Last bit of notes talks about triangle review. Okay? What do we mean? Just so we're all on the same page and you have this in case you ever need to come back to it. This is our identifying angle. We're going to pick an angle. It could be this one. We've chosen this one. Okay? So that's going to be our angle reference. It's our reference angle too. Okay? This one is always going to be the hypotenuse because it's opposite 90 degrees. Based on this angle, this is our opposite side. This angle makes this angle. Sorry, this angle makes this side, and this is the opposite side. And this is considered the adjacent side. If something's adjacent to each other, if two things are adjacent, they're next to each other. So the adjacent is the one that kind of makes part of this angle with the hypotenuse. Okay? So that's the identifying angle, opposite, adjacent. You don't have to write this next thing down, but follow along, please. If this was our identifying angle, then this becomes our opposite, and that is our adjacent. Okay? So this side is going to depend on which angle we're using as our identifying angle, or our reference angle. That's what you're going to hear me say. So we take this, that's the opposite, and that's the adjacent. Okay, so good luck as we start to move forward on things. Really work on following along and work on solving the crane problem.